So we would like to figure out an equation that describes the potential energy due to a point charge. This is what the equation is going to look like at the end of this video. So here we describe Q1 to be our source charge. So it's creating this electric field, right? And Q2 is going to feel this electric field, and it's going to go in the positive x direction away. If this is positive and this is positive. We want to first figure out how much work does it take to move Q2 from x initial all the way to x final. Usually we talk about ds, a little segment along the path of motion. Here we're just going in one direction and it's dx. So we can write out our work equation, which is the force, which is Q2 times E, and it's going from x initial to x final, and then we have E dot ds. All right, now the thing is, like we've had before, we know that E and ds are in the same direction here. We have E going along this direction, ds, which is dx, along this direction. So we can rewrite this as Q2 integral from x initial to x final E dx. Now what is E? We've seen this before, where the electric field due to Q1 is going to be equal to K Q1 over, and then, well, what's the distance between Q1 and Q2? We'll just call that x. And then that is squared. So we're going to take this and plug it in here. So work is equal to Q2, Q1, K, because these are all our constants, integral from x initial to x final, 1 over x squared dx. And this is a type of integral that you should definitely be able to solve, right? So then when I solve it, I get, I can just go a little bit slowly here. We have x of a negative 2 dx. And whenever we have the integral of x to the n equal to x to the n plus 1 divided by n plus 1, right? So then this becomes x to the negative 2 plus 1, negative 1, divided by negative 2 plus 1, negative 1, right? And this is evaluated from x initial to x final. If I rewrite this out nicely, I get Q1, Q2, KE, and then I have divided by x initial minus KE, Q1, Q2, divided by x final. I just swapped the positions around because here we have a negative sign anyways, right? So this is the work done to move charge Q2 from its initial position to its final position. Now, by definition, we know that the work is equal to the negative change in potential energy, which is equal to negative U final minus U initial. If we look at this here, well, I'll rewrite it out one more time. So we have U initial minus U final is equal to x initial minus KE Q1 Q2 over x final. We can see that this is U initial and this is U up, where U is the electric potential energy. That means the electric potential can be defined as KE Q1 Q2 over R, where R is just some arbitrary position. Okay, so this is what U is. And now we can also relate U, this is the electric potential energy, right? We can relate this to the electric potential V, where V is defined as U. Sometimes you can say U sub E to remind you that it's the electric potential energy divided by Q. So that's going to be equal to KE Q over R, like this. And I know sometimes this can get a little bit confusing because here I had Q1 and Q2, and then all of a sudden I only have Q. And this comes from the fact that if you, again, remember from before, so let's say we have positive charge. The positive charge creates this electric field, right? this field, E, is independent of there being any additional charges. When you place an additional charge in it, it experiences a force due to the electric field. So what we see is that while E does not need there to be any other additional charges for it to exist, because E is just a field created by this charge, F, the force, depends on there being this charge because it's a force felt by a secondary object. It's the same thing here, where V, the electric potential field, which is a scalar field, is independent of there being any additional charges. So it's for an arbitrary distance r, right? Where Q here is just the source. So in this case, it's the source here. On the other hand, we have the U, which literally depends on there being two charges, just like F depended on there being some source and then something feeling the effects of that source here. Okay? In the next video, I'm going to go over a problem that deals with the potential energy due to a point charge.